Algebra I, 10.5b, subtract unlike denominators using a pattern for rational expressions. We saw in the previous video that we can add rational expressions with unlike denominators by using this pattern. We used p over q plus r over s as our rational expressions, and we just need to multiply p and s together and add it to r and q multiplied together and put it over qs. See? That's how we were adding unlike denominators. We can modify this pattern to help us subtract rational expressions with unlike denominators. All we have to do is put a minus sign there. See? It's the only difference between them. This one's plus because we're adding unlike denominators, and this one's subtract because we're subtracting unlike denominators. We just change the sign to subtraction and follow the same pattern. So if we've got 5, 6, and we're taking away 2/3, following this pattern, we do 5 times 3 minus 2 times 6, and we multiply 5 times 3 and get 15, and 2 times 6 and get 12. We subtract 15 minus 12, and the whole thing is over 18, the 6 times 3, see? And we get 3 over 18, or it simplifies to 1/6. See how we did that with the pattern? All right? So now we're going to do this with rational expressions, all right? So here's our pattern with the subtraction sign. Whoops, we need a subtraction sign here, all right? And what we're going to do is we're going to rewrite it using this pattern. So we've got x plus 2 over x minus 4 minus x plus 1 over x plus 4. So we rewrite using this pattern. So we're going to do these two multiplied together, x plus 2, x plus 4. And we're going to take away these two multiplied together, and we're going to put it over these two, okay? Now, because there is a minus sign here, and we don't want to distribute it yet, okay? We need to FOIL first. We need to multiply these binomials together by using the FOIL method. So we're going to put brackets around it because we don't want to multiply the negative in yet, okay? We don't want to distribute that negative. So the first thing we're going to do is FOIL these two binomials, write our subtraction sign, then we're going to FOIL these two binomials, all right? And we end up with these two trinomials. Now we can distribute that negative. Now that we've done the FOIL method, now we can distribute that negative sign, okay? So this negative sign is going to get distributed as like a -1, right? Because our buddy, the invisible 1, is really here in between here. Do you remember that from the previous videos? So negative times x squared is negative x squared, right? But a negative times a negative 3x makes a positive 3x, and a negative times a -4 makes a positive 4. See how that happened? Because we distributed that negative sign. And then these guys just kind of go for the ride, don't they? This part of the numerator just moves down here, and then the denominator just moves down here. So now this is our new problem right here, okay? This is how far we've gotten. We can rewrite this to combine like terms. Do you see combine some terms that we can combine? We've got a positive x squared and a minus x squared here. See? Here's the positive one, and there's the negative one. They're pink. Then we've got this positive 6x and this positive 3x, the green ones. Then we got a positive 8 and a positive 4. See that? So we've got pink, we've got green, and we've got orange. And then these colors can be combined to each other. So if we've got x squared minus x squared, that's a 0 pair, isn't it? So that completely cancels itself out. It's eliminated itself. It's a 0 pair. 6x and 3x makes 9x, and 8 plus 4 makes 12. So now we've got 9x plus 12 over x minus 4 times x plus 4. Now we just need to factor this to find common factors that we can cancel out. So we need to factor this binomial, 9x plus 12, all right? And it factors out to 3 times 3x plus 4, see? That would be the 9x. 3 times 4 is 12. That would be the plus 12, see? We put it over our denominator. I don't see any common factors, so we're done. This is as far as we can go. See? All right. All right, let's try this again. Now we've got a whole number here, a 5 minus 5 over x minus 2. We rewrite using our pattern, and we make the 5 as a fraction, like a 5 over 1, so that it's also a rational number. See? Remember, fractions are rational numbers. So now we've got our two fractions. Now we can just use our pattern. 5 times x minus 2 minus 5 times 1 over 1 times x minus 2. All right? Now we just need to multiply and do the distributive property, don't we? So now we got 5x minus 10 minus a 5, right? And the whole thing is going to be over x minus 2 because it's times 1, so it stays the same. Now we can combine the like terms. That 10 and that 5 can be combined, and we have 5x minus 15. Now we can factor to find any common factors that can be canceled out, and 5x minus 15 can be factored to 5 times x minus 3. See? 5x minus 15. See that? And it's simplified, and it's as far as we can go. So remember, a fraction or rational expression is simplified if its numerator and denominator have the greatest common factor of 1. If that's the only common factor they have, then it's simplified, okay? Let's try one last one. We've got 3, a whole number, minus 3 over x plus 4. This one we did minus x minus 2 as the denominator down here. See, now we're going to do it with a plus, all right? So we're going to turn this into a fraction. So we got 3 over 1, and it's going to be minus, x plus 4. All right. Now what we need to do is rewrite it using our pattern. So we do 3 times x plus 4, crossing this way, right here, minus 3 times 1, right? And the whole thing is going to be over 1 times x plus 4, all right? Now we need to do our distributive property, don't we? So we got 3x plus 12, right here, see? Minus 3 times 1 is 3, and the 12 and the 3 can be combined because they're like terms, aren't they? So we have 3x plus 9, because 12 take away 3 is 9. When we bring that denominator down, we just copy it, right? So now we have 3x plus 9, and we need to factor to find any common factors that can be canceled out. And 3x plus 9 can be factored to 3 times x plus 3. See? 3x, and 3 times 3 is 9, so that's our 3x plus 9, see? We put it over our x plus 4, and we're finished. So what we did was we rewrite with the pattern, okay? We rewrite it using our pattern, whether it's plus or minus, and in this case it was minus. We distribute. We had to distribute and multiply. Then we combine like terms. Then we factor to find any common factors that can be canceled out, and we simplify it, all right? So try to keep notes of these. Watch this video again if you're confused, all right? And if you don't remember factoring, there's a link, okay, in this description. Now the next video, 10.5c, we're going to talk about how to add or subtract unlike denominators using the least common multiples. And if you want to see how we did adding the unlike ones with the pattern in the last video, that link is in here. Or how to add or subtract with like denominators when they're the same. Simplifying, dividing, and multiplying. But especially my factoring polynomial playlist or separate videos will be in this description, and it'll remind you how to FOIL, okay? So if you forgot how to do that, first, outer, inner, last, just watch that video real quick for a few minutes to give yourself a review, and that'll help you a lot, okay? All right, I'm still battling this cold, so I appreciate your patience with my voice, and we're going to move on to 10.5c, and I'll see you there. I hope this was helpful. Bye.